again, Hendrik Husky. Love to share, love to learn about mathematics. Today I will explain the basic concept of the linear congruence equations. So let's see this definition first. The linear congruence equation is an equation using a modular arithmetic operator for integers. And we can write this equation as Px congruence A mod B. Px, A, and B are integers. It means Px minus A can be divided by B. Now, before we go more further, let me introduce two things that you should know. The first thing is the GCD, the greatest common divisor between two integers. And second is the Eclipse algorithm, is the method of the divisibility by using the Eclipse idea. And let's see some example here. For the GCD, given two numbers A and B, A is 4 and the common factor is 2 times 2 times 1, and B is 6 and the common factor is 3 times 2 and 1. The GCD of these two numbers are 2. Now let's see the example of the Eclipse algorithm. Given the GCD 4 and 6 is 2, and by the definition of Eclipse, it can be write as the equation, the linear equation, that is 4x plus 6y is 2. And then we do the algorithm of the divisibility. We divide 6 by 4 gives 1 as the result and 2 as the remainder. And you just stop when you reach the remainder, 2 in this case. And then you can write this algorithm as 2 times 4 plus minus 1 times 6 is 2. So, the value of x is 2 and the value of y is minus 1. Okay, after we know to handle this basic concept, we can go to the theorems. The first theorems, given the congruence equation here, Px congruence A mod B, and then we suppose P and A are coprime. Or by the way, the GCD P and A is 1. And then the linear congruence equation of Px congruence A mod B must have a unique solution. But if the congruence has a unique solution, then it is not always true for the GCD P and A always be 1. Now let's to handle some examples. Here we go. Here the equation is 7x congruence 3 mod 9 and find the smallest positive integer of x. Answer: according to the first theorems, and the GCD 7 and 3 is 1, so the equation has a solution. By using this table, we can check the value of x from 0 to 3. Now, if x is 0, then the value of the 7x minus 3 is minus 3. But minus 3 cannot be divided by 9. Next, x equal to 1, and the value of the 7x minus 3 is 4. But 4 cannot be divided by 9. Next, for x equal to 2, and the value of the 7x minus 3 is 11, and 11 cannot be divided by 9. Next, if we put x equal to 3, it gives the 18. 18 can be divided by 9. So the solution here is 3. Let's continue to the second theorem. Given the equation Px congruence A mod B, if S is the unique solution for Px congruence 1 mod B, then the linear congruence equation Px congruence A mod B must have a unique solution, that is, x equal to A times S. Let's see the example. Here, we must find the solution of the integer x given 25x congruence 3 mod 17 9. Answer. Because the GCD 25 and 3 is 1, so by the definition, the first theorem, the equation has a solution. So, solving by the table is not efficient anymore, because so many numbers we have to check from x equal to 0 to x equal to 79. Next, we must consider first the value of x from the equation 25x congruence 1 mod 79. So we can write this mod becomes 25s plus 79t is 1. Now we start the algorithm. We divide 79 by 25 first, and it gives 3, and the remainder is 4. And we can write this as 4 equal to 79 minus 3 times 25 as the first equation. Second, we divide it again for 25 by 4. And the result is 6, and the remainder is 1. We just stop here because the remainder gives 1. So, from this divisibility, it gives 1 equal to 25 minus 4 times 6. Now we just substitute the equation 1 to the equation 2. So we just write 1 equal to 25 minus 79 minus 3 times 25 multiply by 6. And we get 1 equal to 19 times 25 minus 6 times 79. It means the solution S is 19. Now we start again from the conclusion before. 25x congruence 1 mod 79, and it gives 25s plus 79t is 1, and we get s equal to 19. So, according to the second theorems, the solution for the 25x congruence 3 mod 79 gives from this formula x equal to a times s. It gives 3 times 19, the result is 57. And now we can go to the third theorem. The third theorem, given again the equation Px congruence A mod B, and suppose the GCD of P and B is B, then if B cannot divide A, then Px congruence A mod B doesn't have any solutions. And again, if D can divide A, then the equation Px congruence M mod B has as many as D solutions, which all of them are congruent with this. P over dx congruence A over D mod B over D. Now, let's try the example here. Now, the example here gives 48x congruence 136 mod 968. Find the solution of integers x. Answer: because the GCD 48 and 136 is 8, we cannot decide this equation has solution or not by the first theorem. So, we will apply the third theorem. According to the third theorem, we must find the GCD 48 and 968, that is 8. And also 8 can divide 128. So by the third theorems, it has 8 unique solutions that congruent with 6x congruent 17 mod 121. To get this equation, you just divide all by 8 for the first equation, and you will get this. Next, we know 6x congruent 17 mod 121. The GCD of 6 and 17 gives 1. By the first theorem, it must have a unique solution. So, first, we do the Euclid algorithm to solve the 6x congruence 1 mod 121 first. And we write this equation by the linear equation 6x plus 121y is 1. Now we do the algorithm. 121 divided by 6 gives the result 20, and the remainder is 1. And we can write this, because the remainder is 1, we stop here. And we can write 6 times minus 20 plus 121 times 1 gives 1. So this s, the value of s is minus 20. And we can say the solution x asterisk is minus 20 times 17. So the solution in this case is minus 340. Because the solution for this equation is minus 340, but it doesn't give the unique solution. To get the unique solution, you have to find 8 unique solutions that you must search the x first to get from 0 remainder from modulo 121. And here we go, minus 340 congruence x mod 121. And it gives x equal to 23. Why? Because minus 340 minus 23 gives minus 363. And minus 363 is divisible by 121. So, the first solution is 23. And for the other solutions, you just add x1 by 121 till you get rid at x8. So the other solution here, x2 is 144. It comes from the 23 plus 121, and so on. And you get x3 is 265, and x4 386, x5 507, and x6 is 628, and x7 is 749, and final is x8 is 870. So I hope it can help you for your study. And finally, we have learned the basic concept of the linear congruence equation. Thanks for watching, and bye-bye. Don't forget to subscribe me. Thanks.